Hi everyone. In the last video, we covered about type deck, pide, and take and data classes. So now we'll cover the state reducers. So let me select this kernel. Okay. Uh, yeah, started. See, we already know how to use a type deck and how to use this, so data classes, pide, and and all those stuff. Now we have one node, so that is this is the method and this is the state we given one variable name as foo class variable. It is the its data type is int. uh, okay, so we created one method that is node one, and what we are doing is like whenever user is calling this object, sorry, this variable, he's incrementing that with one. Let's say this integer is already some one. After that, 1 plus 1, it will become 2. Okay, so whatever value he's passing, it will be added and it will return that. This is the method. And you already build one flow. Like using the state graph, you are passing this add node and add edge. So you're creating one entire flow, like from start to end, one node. So this is the, okay, let me run this. And I'll explain you like how reducers will work and how it's going to be helpful. Let's say if I run this, then we have only one node that's going to execute. Then foo initially it is one. One it is passed. State of foo is one. One plus one two. It will become two. We got this. It's good. Then what we did, we created another two nodes. So total three nodes are there. You can see this. It's a same state, and we're incrementing same method. All the logic is same. But what we did, so we created edges and we created from node 1 to node 2, node 1 to node 3, node 1 to node 2, node 1 to node 3. In that way, we did. Here we'll get some error. Why? Because, uh, so the method logic is same, and the problem is from state 1, from this node 1, it has to call node 2. At the same time, it was has call node 3. There is no condition available here. And let's say in earlier cases, we have some random, random method and random condition is there. So if it is greater than 0.5, you have to go for node 2, otherwise node 3 in that way. But at this moment, there is no condition. And also another problem is the the state is same. State of foo, state of foo, state of foo. Then it's already in node 1, and after that, which one it going to be, execute? There is no such thing. Node 1 to node 2, there is no condition. Node 1 to node 3, there is no condition. Then how it's going to execute? If you execute this, we'll get some error. Node 1, node 3, there is a key foo, so it was till this node 1, it is fine. After that, node to node 3, there is a ambiguity will come because the same state, there is no condition. Then how it's going to vary, right? So in this place, you can see this node 1 has branches node 2 and 3, but node 2 are running parallel because there is no condition. They're both attempt to override the same state within the same step. Then there is an ambiguity will occur because we don't know which one it has to pick. At that time, one solution is using reducers. Reducers is nothing but like you can think, this annotate method you already know. This is the data type, and after that, this is the operator you have to do. From the operator, you can add this to simply addition. And what it was doing is it's a list. Okay, so foo of 0 plus 1, it was passing. What it will happen is like it will append, like earlier one value is there, after that it will add it to next element. In that way we are overcoming this problem. You can see the same example. If you run this, if you give this one, it will become foo of 1 comma 2. Earlier it was 2 direct value you are getting. Now the previous value as well as the current value you are getting. Now same example, in the same, in the top we have this three nodes, right? In the same way we created three nodes. You can see the state also, right? You can create a state. This is nothing but the last value and minus one, and after that plus one it was doing. And same condition, it was the same, flow. This is the same flow, line flow diagram. And if you give this one, now it will execute it. There is no issue. Initially it was one. Initially it was one. After that, node one is called. It was added plus one. So total it become two. And after that, at the node two, it will go to node two, and two plus one three. Node three also two plus one three. It will become three. In this way, it will happen. So the reducer, what it will do, it will perform operations concurrently. That's the advantage of having these reducers. How reducers is nothing but simply one annotated, you can say that is one of the reducer function, right? Like instead of normal way, you are adding some list. You're dealing with list so that it will be appended. So that's the logic. That simply you can consider it as one of the reducer. These functions will be extremely useful when you're going for so huge implementation. Now what it will do, so you added none, it's a integer, right? If you do this, it can't, none, it won't occur, so that it will give some error. So but you can create your custom reducers. This is another point. Okay, so these things you can refer, it's not a big thing, I can say. So you can see this, whatever happens, it has to return to uh it has to return this list of two, but you're passing none, so at that time don't it will give some kind of error. But now we can deal with these things, right? How you can going to deal with these things, in that way they created some examples. Okay, so now another state is messages. Messages you already know, like message state from the LangGraph.graph you can get this, and after that there is a graph message, add messages you can do. What this advantage is, like you created one custom class, and after that there is three things. One is messages. You are adding key one and key two. It's nothing but strings. You are extending those messages. So total there will be four keys. I mean, I'm just saying as an example. So you given from this lang core messages, you are taking this A message and human message. You given some random message. Um, you want to, what you have to do, you want to rewrite these things in the same way. So the major point here I want to cover here is, you can give ID also. ID values you can do. Let's say initially the ID is 2, that is associated with this message. I'm looking for information or marine biology. But in the new message, it was changed to I'm looking for information on whales, not on marine biology specifically. The same ID it was given. So what happens? It will override that. You can see this. If I execute this, earlier initial messages are this. I'm looking, hello, how can I assist? I'm looking for this. But now with this new message, it was replaced because of this ID, right? So that's the advantage of this rewriting. So here, what is our purpose is reducers we covered. We're covering like how we can rewrite the existing things, how we can overcome that. So that part we are covering. And also there is another important thing that is known as removal. Let's say you have some messages, you want to remove that. How are you going to remove that? There are two ways. One is based on ID. By default, that's why we are using this AI message, human message from the LangGraph. Why? Because it will give you all this identifiers, like kind of metadata you can consider. So from this ID, you can identify the things, what message you passed, and all those information you can capture. Let me run this. You can see this. What I'm doing, I'm last like previous two messages, I'm just removing. Okay, so you can see this. Hi, hi. And then so you said, so it was giving remove messages for messages and messages till -2, like till the end 2, right? So from the beginning onwards, before the previous two. So that's why the first two messages will be disappear. So you can see this. Only last two, I mean, in case if I added one more message, then last three will come. Let's say we'll do one experiment here. I'll copy this and I'll just add one more message for better clarity. I should, but what others do? I'm adding this as 5. Okay, you. Let's try this. Okay, now removal ID1, ID2. You can see this only ID1, ID2 is removed, and these three will be executed. If you look at this, you can see this. What should others do? But what others do? So these things like add messages. we can see that messages id2 has deleted messages and removed by the reducer. Okay, so the last two things you're going to get and in the add messages space. That's the advantage of this. Like you can delete the things, you can execute the things. So with the help of this remove message, you can remove the messages from the given context. So you can set the messages, you can add messages, right? Uh, this is the add message method itself. So initial messages, whatever new message you are doing, that will be added to the this entire context. So okay, so what we did in this video is like we covered about reducers. Let's say you have this kind of a two ambiguity state, how you going to handle it. Okay, so one is like annotations. Using that annotation method, you can pass list append, these kind of things you can apply. You can handle that. That is one way. In case you are dealing with numbers, means another thing what we covered is like we covered about this. From the LangGraph, we have this messages, remove messages, add messages. That part we covered. Okay. In the next tutorials, we'll see some more things. And till then, take care. Enjoy.